Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, I explained how to create a 3D Torus wireframe. In this video, I will show you how to create a Torus wireframe. The main purpose of this example is to illustrate how to construct the vertex positions for 3D objects using parametric equations. The torus can be generated by rotating a circle in 3D space about a specified axis, as shown here. It can be described by a set of parametric equations like here, x, y, and z. Here, the capital R represents the radius of the torus ring from center to the center of the ring. The small r represents the radius of the circle. Here, u and v are parametric variables. To create a torus wireframe, here we divided the surface, use the tube ring and the circle ring here to form a surface grid. You can see here. The unit cell is formed by 4 vertices and 4 line segments. You can see here. For each unit cell, we only need to draw 2 solid lines from P0 to P1 and P3 to P0. Because the 2 dashed line segments will be drawn by the other cells, this can avoid drawing the same line segment multiple times. In this way, if we run over all the grid, we can create a wireframe for the entire surface of the torus. Okay, let's go to the programming part. Again, we will use the git tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download all the source code used in the last video. Now let's open a command prompt window and run the following command: git clone, and paste this link. This will generate WebGPU 15 folder on your local machine. This folder contains all the source code used in the last video. Now we want to make a change to this folder. Rename WebGPU PU16 and cd into it. At this point, we are going to start Visual Studio Code with the command code period. Okay, this is Visual Studio Code interface. We can close this welcome page. Here contains all the source code used in the last video. Now open a new terminal window and run the command npm install to restore the npm packages. Okay, finished. Now all the installed packages are stored in the Node modules folder. In this example, we can reuse the common TypeScript file called wireframe.ts that we have used in the last video. Now from the src folder, open the mathfunc.ts file. This file contains the math functions used to create different wireframes. Now we need to add a new method called torus position to this file. So we add a new method here. Here is the code of this new method. You can see here the input argument contains the center parameter. This parameter lets you specify the location of the torus. This torus position method simply returns the x, y, and z coordinate positions. This position is specified by the parametric variables. Now we can save this file and close it. Next, open the vertex data.ts file from the SRC folder. First, we need to introduce the Torus position method from the math.func.ts file. Then we add a new method called Torus Wireframe data here. You can see this new method contains capital R here and small r, as well as capital N and small n here. The capital N and small n are divisions for the UV parameters. Here we first get the positions for our grid point by calling the Torus position methods here. We then draw the two solid line segments here from P0 to P1, another P3 to P0, as shown in this unit cell. P0 to P1, P3 to P0 is two solid line segments. We don't need to draw these two dashed line segments, so this P2 is not used. So these two segments are consistent with this diagram. You can see here we have a flag method here. We use this method to create a new flat 32 array from sub-arrays here concatenated into it. So we can now save this file and close it. Next, we need to make some changes to the index.html file. From DSRT folder, open this file. First, we need to change the 15 here to 16 because this is the 16th video series. Here we need to change the H1 title here from Chrome wireframe to Torus wireframe. Next, we need to change the input parameter. So we need to change this parameter because this parameter is for the Chrome wireframe. So we need to change the parameter for the Torus. Replace this parameter with this code. You can see the large r, small r, large n, and small n. All these parameters is specific for the Torus. Now we can save this file. Next, we need to make some changes to the main.ts file. Open this main.ts file. The code here is for creating the Chrome wireframe, so we need to replace the content of this file. You can see here we first introduce the Torus wireframe data from the vertex data.ts file. Next, we need to change the input parameter. You can see here we change it to capital R, small r, capital N, and small n. This parameter is for the Torus. Inside this message, we call the Torus wireframe data to get wireframe data. Then we call create wireframe methods to create wireframe. Here are default parameters. You can see we define the capital R to 2 the radius, and a small r for the circle is 0.5. Capital N is 30, little n is 15. So then we call the create 3D object methods to create our default Torus wireframe. This part of the code allows the user to recreate Torus wireframe by changing the input parameters. Now we finish the modification to the main.ts file, so we can save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bound our code. npm run prod to bound our code. Okay, the bound file is created successfully. Now we can click the Go Live link to open Chrome Canary. You can see this is the Torus wireframe shows on this page. We keep rotating. Okay, we can make some changes to input a parameter. For example, we change the large r to a very small number, for example 0.1, and the small r we change to 2, and we change this to 50 and 25. Then click this redraw body. Now we actually get a sphere wireframe. Now we can change back, change to 2, change to 0.3, and then click redraw. So we get a Torus wireframe back. You can also click the camera control button here. Then you can use your mouse to control the motion of this wireframe. For example, you can rotate and the pan, and also zoom out, zoom in, zoom out. If you click animation again, it will animate automatically. Now we have completed this example. I have created a GitHub repository to host the source code used in this video. I will post the link for the source code below this video. You can click the link to download the source code. I will end this video here. In next video, I will show you how to build a light model in WebGPU. See you next time. Bye.